Now we'll just talk about some best practices and recommendations. I guess first note that pressure reduction isn't just a set point change, it's an engineered strategy. So you're going to want to consult experts. This is probably the biggest cost here is the feasibility study of it. The actual change, unless there's equipment replacements required to accommodate the change, the actual change is just changing the set point of the boiler. Um, and so, but you are going to want to consult the experts and have them document average and peak steam loads, verify piping sizes, insulation, trap conditions, PRV capacities, review historical issues like leaks or carryover or water hammer, um, consult boiler manufacturers to check nozzle sizings and boiler performance at lower pressures, evaluate the feed water pumps, flow meters, steam traps, and PRV performance at lower pressure, and evaluate impact on pressure drop and steam velocity. You also want to test before doing the permanent change. So it's recommended to do like a short-term test where you're dropping the boiler pressure in 10 to 20 pound increments. You monitor system conditions, observe for any problems like water hammer or wet steam, and then go from there and confirm that that everything's okay and that you should be able to continue at that lower pressure operating point. Some other recommendations. You want to fix the basics first. So you want to fix your trap failures, your leaks, your insulation gaps, water chemistry, which can lead to carryover, as we mentioned, any blowdown issues. I mean, if you are having any issues with carryover, with water hammer, a lot of these measures, fixing these things will mitigate those problems, and then you can proceed with trying pressure reduction. But if you're already having some of these issues, like water hammer or poor water chemistry or blowdown, you may exacerbate the problem by lowering pressure. Now, you will mitigate losses through trap failures and leaks and insulation, poor insulation, but but still you would want to address those problems anyway. You want to pair with monitoring tools. So you want to install new or recommission and calibrate existing steam meters so you can see the impacts. You're going to want to, that'll also help you if you are not hitting set point in any of your buildings to see what the demand of that building is and what the impact on the pressure reduction is. You're also going to want to trend that data and and validate load distribution, like I was saying. Also consider system. So one of the concerns here is your steam trap performance. A steam trap monitoring system can track that performance over time and kind of show you problematic trends. Instead of just the data in there is pretty interesting. Instead of just noting when a trap has completely failed, you can see the cycles. You can see the cycles increasing over time or whatever the case may be, and maybe get a better idea of why that trap is failing, if it's overloaded, if it's a poor application, or if it's just maybe you start to lose faith in that manufacturer, or whatever the case may be. But it gives you more insight. You should also consider system parameters. So as we just showed in our case study, not all facilities see the same savings. The best results are going to be when the boilers are oversized, if there's long, high pressure distribution runs, if there's a lot of traps, and especially if they're paired with a high failure rate or poor trap maintenance history, if there's poor insulation coverage, if there's frequent steam leaks, high fuel costs, which basically will, increase the value of any system savings, low boiler efficiency along the same lines. If it's continuous operations, a lot of run hours, then obviously that's going to increase your savings. Also, if there's poor condensate return, that basically contributes to a low system efficiency, and then any steam conserved has that much more impact on your bottom line. There's a lower benefit when there's short, efficient HP runs. If there's minimal pressure reduction across PRVs, so like If you have an 80-pound system and you have PRV stations that are dropping down to 60 pounds, you probably don't have a lot of room to drop your high pressure side pressure because you can't operate the PRV, say, at 70 pounds upstream and 60 pounds downstream. So if there's a lot more room there to reduce that pressure, then you're going to have a better benefit. If there's not, then you have a lower benefit. If it's a well insulated new system, efficient distribution system, you're going to have a lower benefit because there's just less losses.